In this lesson, we are going to learn how to import models into our Three.js scene. Why do we need models? Until now, we used cubes, spheres, stuff like that. And we can build like a cute little house. But if you want to create like really complex models, like a human, an alien, spaceships, you better use models that you create in software like Blender, Cinema 4D, 3ds Max, Maya, and stuff like that. Once you have created this model, or you take it from someone else, maybe you are working with a software, a 3D designer, stuff like that, you have to import this model into Three.js, and you will have to choose the right format, the right data, how to handle the files you just loaded. And we're going to learn how to do that here. We are going to use pre-made models. So I will put, I did put models inside the static folders. You will see where those models come from. It's interesting. But anyway, later we are going to learn how to create our own models by using Blender. It's going to be a great lesson. But for now, let's use the models inside the static folder. First, we need to talk about formats because there is a lot of formats when it comes to 3D. And the formats, they made multiple formats because they were responding to a problem, like what data is inside that file, the weight of the file, the compression, the compatibility, the copyright, stuff like that. There are formats that are just associated with one software, like a 3ds. You also have like blend file, stuff like that. And we need to choose one. And there is a lot of formats. As you can see, I put a link to a Wikipedia page with all possible, not all, but almost all. I think there is a lot inside, possible format. And as you can see, there is a lot of formats. And we are going to test each one of those. I'm kidding, don't worry. We're going to focus only on one format, but talk about why there is so much format. So yeah, there is different criteria. If you want to load a model, you have to choose the format according to different criteria. Maybe you don't have a choice, like you don't know how to use 3D software. Someone provided you a model and then you have to use it. But it's better to have control over the format, to tell the person doing this file, I need this because of these criteria. So the different criteria, well, you can have some file dedicated to one software. The file can be light, but it will lack specific data. So it's great to have a very light file, but if there is not the data you need, well, it's a problem. You have format with almost everything in it, but the file will be so heavy that your website will be too heavy to load. You have format that are open source. This can be really interesting. There are format that are not open source. There are format where you have binary files, so you cannot change easily the things inside, and some which are ASCII files, so you will be able to tweak things just by opening the file in your editor. Well, there is so much criteria, and that's just a glimpse of everything you can have. And by the way, you can create your own format. It's not that huge. I mean, it's just exporting very specific data. I did it with Blender in Python. It's not that hard. You just have to export the very specific data. For me, it was just because I needed like Bezier curves, stuff like that, with a very specific precision. Well, I didn't have any format in all of those, so I did it on my own. So it's possible, which is why you can have infinite formats. But they are popular formats, and maybe you have heard of those. You have the OBJ, simple, efficient, a lot of data inside, maybe not all the data, but anyway, you have FBX, you have STL, you have Poly, so it's PLY, you have Collada, you have 3ds for 3ds Max, quite sure it's associated with this one. I did use it quite a lot. I liked how light the file were, and you have GLTF, all right? There is a lot more, but to me, these are the most popular. I used each one at least once. But currently, there is one format which is becoming a standard and should cover most of our needs. And it's the GLTF, all right? But be open, there is a lot of formats. It depends on your project, but the GLTF will cover the needs we are going to have in the following lessons. And in this lesson, obviously. So GLTF is for GL transmission format. Okay, why not? It's made by the Chronos Group, which is very interesting because the Chronos Group, the guys behind OpenGL, WebGL, Vulkan, Collada. If you don't know any of those, well, you know about WebGL, I hope. You wouldn't be here. But it's just great stuff in 3D. I won't detail everything. And you have many people inside that group, like AMD, ATI, NVIDIA, Apple, ID Software, Google, Nintendo, just to quote the biggest, but you have many companies behind this group. So it's a common effort, which is great. And it became very popular since few years. Okay. GRTF supports different sets of data. You can have the geometries and the material. This is kind of obvious, but sometimes you don't have those, but GRTF support this. But you also have more data, and this can be really interesting, like cameras, lights, scene graph. By scene graph, I mean the scene, but you can have object in object in object, just like we did with the group in Three.js. Some format doesn't have this. So now we have scene graph, animations, skeletons, morphing, and many more, which is great. That means that you can export like a full scene and get it inside Three.js, and you will have the camera at the right place, the right light with the right values, and stuff like that. And your object with geometries material will look like it was looking inside of Blender. You have various formats, because GRTF is a format, but the files you can export can have different formats. It's going to be JSON, binary, embed texture. We are going to talk about this later. And it's becoming the standard when it comes to real time, not only real time, but I can see a lot of GRTF when it comes to real time rendering. And most 3D softwares, game engines, and libraries support it. And this is great because that means that you can have a very similar result between those, like between Blender, Unreal Engine, Unity, Three.js, and stuff like that, Babylon JS too, you can have a very similar result. Anyway, you don't have to use GRTF in all cases. All right, if you just want, like a geometry to create particles, like you have an object made of particles, so you've modeled the object inside, Blender, and you want to use the vertices to create particles inside of Three.js, you don't need GRTF. You can go with, Polyfile. I did it for particles, I used the Polyfile file, and it was great. Less data, easier to integrate, anyway. Question the data you need, the weight of the file, how much time to decompress it, and stuff like that. Don't always go for GRTF. So we need models. So where can we find models? Well, the GRTF team provides various models just for testing. So it's great. We can just use their models in our experiences to test if it's working. So it's exactly what we are going to do. As always, you have the links in the links panel. And as you can see, this is the GRTF repository, the GRTF sample models repository. You have two versions. Let's go on the second version. And here are all the models you can use. It's great. We have a lot of things. We can have very complex models like this truck, a duck, like this sci-fi helmet. We have Susan. We talk about Susan. It's the monkey. We have those. We are going to use both of those. So it's great. But you also have access to very simple examples like a triangle, just a triangle, and then an animated triangle, and then morphing and more complex stuff. So it's great. You even have a choose and a chair. All right. If you want to use those, you can go to the right folder, or you can clone the whole repository. Be careful, it's kind of heavy because there is a lot of models inside. So you can clone it or download it anyway. What I did is that I put the models inside the static folder. So you can go into static, so it's there, static models, and you have a duck, a flight helmet, and a fox. And we're going to use all of them in different situations. You will see why. So more theory, and then we start to code, don't worry. So you can have different formats. All right, GRTF is a file format, right? But you can also have different GRTF files format. And we are going to start with the duck. It's a great example. And as you can see in the folder, so we have the screenshot, we have a README, great, but we also have four folders: GLTF, GLTF binary, GLTF Draco, and GLTF embedded. And we're going to talk about each one of them. Why? Well, because it depends on what you need exactly. Each one we have features that can be advantage against the other, so you need to understand those and how to handle those, because there are some that we need extra effort to make them work, but for good reasons. You will see why. Yeah, be careful, your OS might hide the extension of some of these files, all right? I don't know if it's the case for me. No, I made sure that my Mac is showing every extensions, but be careful of that. Your OS might hide them. What I recommend is to use the editor. If you open the folder in the editor as we did until now, you can see the files here. So inside the models, I have my duck, and in the editor, you will always have the right extension. All right, don't trust your OS. Your OS will try to hide extensions. It's a common mistake my students do. All right. So yeah, let's talk about the different format, and the first one is going to be the GLTF. All right, it's this one right here, and we're going to test this format first, and it's kind of the default one. It's not exact to talk about a default, but anyway, we are going to say GLTF default. You have multiple files in it, all right? This is our duck. So you've seen it maybe in this part. So the duck is around here. Yeah, this is the duck, and we have multiple files, which is strange because there is only one duck. Why do we have multiple files? First, there is the duck.gltf, and you can open this one inside your editor, and it's just JSON. And you have a lot of informations in this one. You have coordinates, you have things about the camera maybe. Yes, we have it's a perspective camera with those properties. All right, and we have a lot of things, but I don't think we have the geometry in here. The next file is duck0bin. The duck0bin is a binary file, so if you try to open it, nope, you can't. And it contains data like the geometries, all right? It's buffer data like a vertices position, UV coordinates, normals, colors, and you can have more. So yeah, it's kind of, in our case, it's just the geometry with all the data associated with each vertex. And then the final one, you can guess what it is. It's an image, so it's a PNG file, and it's the image that is put on our duck, all right? It's the texture of our duck. The idea is that when we load this GLTF file, we will do that later, automatically the other files will be loaded, and you can find those. If I search for duck0.bin, as you can see, the buffer is the file is referenced here, and if I search for duckcm JPEG, it's here. All right, you load this file, and the rest will be loaded automatically by the loader. Okay, we will do that later. Don't worry, it will make more sense. The next one is the GLTF binary. First thing we can see is that it's only one file, and because it's a binary, we cannot read it. All right. Next thing about the weight. What is the weight? It's 120. All right. Let's keep this part in mind. And it contains all the data we talk about. And yes, here we have this weight. So it's 16, a little more than 100. It's kind of the same weight, almost. And it's a binary file. It's usually lighter. Usually, it depends on your models against which other formats. We are going to talk about this. And it can be easier to load. Like if you load the file on your own, we're going to use a pre-made loader, like a class that will do everything. So it's not very interesting here. But if you are creating your own thing, your own loader, it might be easier to load just one file. And actually, it will be good for us at the very end of the lesson. You will see why. But we are going to need one file models. So it's going to be great because we will have this duck.glb. The problem is that it's harder to alter. Like if you want to, I don't know, change the texture for to change the color of the duck, you can't. You can't just modify, if you open this file, you can't modify the texture inside of it. With the GLTF default, we can just open this in a GIMP or Photoshop and change the color. In the GLTF binary, we can't. Next one is the Draco. The Draco, it's like the GLTF default because we have multiple files, but the buffer data are compressed. It's much lighter. Just look at the weight. It's 45 and the GLTF was 123. It's so much lighter. More about this later. The fourth one is the GLTF embed. It's again one file, but it's one file that I can read. And this is JSON, all right? So it's JSON, but the texture and the buffer, so it's like this one, the first one we saw, so it's JSON, I can open it again, it's this one. So yet again, it's JSON, but the texture and the geometry, so the buffer data, are embedded inside that JSON, which is kind of strange. So this one is like the first one with only one file. We usually don't use this one because it's quite heavy. As you can see, it's the heaviest of them all. The only good thing about this one, it's just one file. All right, cool. So which one should we choose? Well, it's a matter of how you want to handle assets. Do we want to be able to change the textures? Do we want to be able to open the file and change, I don't know, the camera and change the perspective, the aspect ratio of the camera or stuff like that? It really depends on that. But also, if you need light files, or you can have heavy file, and if you can handle those files, like the Draco one, and we will talk about the Draco one later. Many different situations. It really depends on you, and we will see that we will have more information during the lesson. Anyway, you must decide if you want to use the Draco compression or not, but we don't know what is this Draco compression yet. We are going to talk about this later. All right, this is a special one. About the setup, not much to say. Oh yeah, actually we have a few things to say. I already have the setup running. I don't have anything but a floor in it. I have an ambient light and a directional light. I had it in the previous lesson, but this part is interesting here because when you import a GLTF file, GLTF is to have realistic models, and usually we get PBR materials. And actually you can see that inside the duck.gltf, so the default one, and I think you can search for PBR. Yeah, as you can see, the materials, when you export from, I don't know, Cinema 4D, Maya, stuff like that, in GLTF file, it's going to, because it's a standard, GLTF is becoming standard, it's using standard principles like PBR. Remember the PBR? Physically based rendering. It's to have something that looks realistic with some great formulas. Anyway, because it's PBR, because we want something realistic, usually when we export GLTF, we get PBR materials that we create mesh standard materials inside of Three.js. And as you can remember, if there is no light, we can't see anything. So which is why we have an ambient light and a directional light in order to see the models we are going to load. And we have that UI, but we won't be using it. I'm quite sure of that in the following part. So how do we load the model in Three.js? Finally, we're going to code. First, we need to load the GLTF loader. And you probably know about loaders. We've been using texture loader, font loader, cube texture loader. So it's at least the fourth one we are using. And it's the GLTF loader. Good news, it works like the other loaders. So we can use it quite easily. Let's open our script.js file. I can hide the sidebar. And I will import the GLTF loader because this loader is not available inside of Three. You cannot do Three GLTF loader like that, all right? Because this class is quite heavy. There is a lot of code inside, and the Three library would be too heavy if you had those kind of class in it. So to get it, it's like getting the orbit control. We have to do import GLTF loader from, so it's the 3 dependency, examples, GSM, loaders, and yes, we have many loaders inside of it. Actually, I think it's a good thing to check this. I will show you later. Loader.js. We are going to focus on GLTF loader, but be aware that you have access to many more. So yeah, let's have a look. I can just show you. As you can see inside this loaders folder in the 3 dependencies, you don't have to do it, just watch my screen. You have many different types of loader. Oh, that's a Draco loader, interesting. FBX, GLTF, and many HDR, cube texture, NTL, why not? OBJ loader, we have different OBJ loader, poly loader, PLY loader, SVG loader. Okay, all right, that's interesting. So I have many loaders in here, and you can use them if you want. And you can also create your own. But GLTF it's a lot of work, so we are going to use the class. All right, that's cool. We can load things. I will do it right after the base, like this. And I will load models, so I can put like models, and we have to instantiate the loader, just like we instantiate the texture loader or stuff like that. GLTF loader equal new GLTF loader, just like this. You can log it just to test if we imported it and instantiated it properly. No error, great. If you have an error, pause the video, fix the error, and come back to the video. Just like the other loaders, we can use a loading manager. Remember the loading manager to materialize the events, know when everything is loaded, or know when all the scene loading is progressing. If you don't, do not worry, we have a lesson when we are going to use the loading manager. Anyway, you can use a loading manager with the GLTF loader. All right, then we can use the load method. So great, it's like we used to do. GLTF loader, load. We have to pass, we can pass 3 parameters. So first, it's going to be the path of the file. So for us, it's inside the static folder, then models, duck, be careful with the uppercase. And it's going to be the GLTF first. Let's start simple. So I will write models, do not write static, all right? This path starts from the inside of the static folder. Duck with a uppercase D, GL, TF, oh yeah, be careful with this one. The T and F are uppercase, but not the G and L. I don't know why exactly. Duck with the uppercase D and GLTF. If we did a mistake here, don't worry, we will have an error in the console. And then we can put many functions. So it's callback functions. I will put 3 callback functions, and you can guess what are those. We have the success function. We have the progress function. This one will be more interesting. And we have the error function. Put them just to test them. We are going to get rid of progress and error after, but it's a good opportunity to test those. We can refresh. We have a progress, a success. Looking great. If you did a mistake, I don't know, I put duck with 2 U. Yeah, we get an error. So we get progress and then error. All right. If you have an error, pause the video, fix the error, and get back to the video. Okay, cool. I can get rid of the progress and error because I don't need them for this lesson. If you want to keep them in case there is an error, just do it. When we load the model, we can get access to what has been loaded by putting anything here. All right, I'm going to call it GLTF, and we can log the GLTF to see what's inside. And we get a lot of things. And we're going to talk about this. When you load a model, the model just don't happen on the scene. You have to load it and do something with what has been loaded. We're going to do what we need to add the model to our scene. So yeah, let's try to understand what's inside that log. So we have animations, all right, interesting. Maybe we will use it later. We have assets, cameras, oh, interesting. We get direct access to cameras, and we can have multiple cameras. That can be interesting. Not in our case, but anyway. Parser, we don't care. We have scene, which is singular, interesting, and we have scenes, which is plural. This is very interesting because you can export a GLTF file that contains multiple scenes. Why not? Like if you have multiple scenes, that one in this place on Earth, one in space, and one stuff like that, and you want to export everything as one file, you can do it. But there is a scenes, which is an array with one element, but we also have access to the default one. All right, so look my cursor, this group, so the scene singular is the same as the first element inside that scenes array. And we are going to use only the scene. And we have user data. It's when you add more data to your file. It's possible, but we are not going to use that. All we need right now is inside the scene property. All right. We have some informations, but it's actually a 3 group. All right. It's the group class. It's this one. So we get a lot of things inside, and we get access to the children of this group right here. Inside our children, keep up with me, we have an object. So an object, it's like a group, all right? Group is like an object. It's almost identical to an object. You can see it in the documentation, and it's just to contain things. And inside that object, you can go to the children of that object, and we have a perspective camera and a mesh. Wow, that was far-fetched to get our mesh. So our mesh is in the scene property, then the children, which is an array. So it's the first element, which is an object. Then inside that element, it's in the children, and it's not the perspective camera. So that's a bummer because we don't want any camera. We already have one. It's inside the mesh. So it's the mesh. Our duck is right here. How can we get this duck in the scene? And we are going to do that. One more important thing we didn't see because I forgot is that the object, see this one object that contains the perspective camera and the duck, it has a scale. Look at the scale. So let's see the rotation. Not much to say about the rotation. Let's see the position. All right, the position is at the center. I always recommend when you're just trying to figure out what you loaded to watch the position, the rotation, and the scales. Rotation is not that important, but position and scales are. And as you can see, there is a very, very, very small scale. All right, it's 0.01, close to 0.01, which means that the object is really small. And if we add only the mesh, we will get something like 100 times bigger. And if we add the object with the mesh inside, we'll get something 100 times smaller. So we have to be careful with that. We have multiple ways of getting the duck in the scene. We can add the whole scene, all right? And this is what usually people do. And we are going to do that later. But because the scene, so the scene property is a group, you can just add the group to your scene. So it will be a group with an object, and this object will contain the mesh. So it's something inside something inside something. And we add these whole things inside our scene. It's not great, but it will work. And we will do that later. So it's the first solution. We can also add every children of that group. So the scene group, and add all its children, which is kind of a good idea because the scale will be preserved. Remember that the scale, the strange scale we had is on the object, but the problem is that we are going to get all the children of that object. So it means also the perspective camera. It's not that bad. We don't care about having a perspective camera that we don't use. It will not mess with our actual camera. But if you like me, you're kind of maniac, you don't want things that are not supposed to be here, maybe you want to get rid of the camera. But still you can do it. You can add every children of the scene group. So we have only one. You can also filter the children before adding them to the scene. This can be hard because you have to traverse the whole structure of things you have and filter them, say, no, I don't want this, yeah, I can keep this. And it can be really long. And if you have new things inside of it, you are not prepared for it. I mean, it's a lot of work to filter those. Then you can add only the mesh, which means that you will just add. So you will go through it. So we do your GLTF, then the scene, then the children, then the first children, then its children, and get only the second children. You can do that. The problem is that you will get a huge mesh because the scale is applied on its parent and not the mesh itself. You can check the mesh, look at the scale. Yeah, it's 1, all right? So the scale which make the duck the right size is on its parent. All right. Finally, you can open it in your 3D software, get rid of this object parent, make sure the scale is applied to the mesh and get rid of the camera and export it again. All right, which is usually what I do, in fact. But anyway, I just wanted to show you every possible ways of doing things, and we are going to use some of them. We are going to add the object. All right, I get back to the group. This is our scene. We are going to take only the first child of its children array, children property. It's a good start. Let's start with that. This way we'll have the scale apply on the object and no surprise. So let's go. So the GLTF is what I've been logging inside the console for now. And I can do scene add GLTF scene children, and it's the first and only one, like that. And it worked. Great. So sometimes it's that easy, but you will see later that a duck is quite easy. It's only one element. We see that it's not that easy when it comes to other models. Anyway, what we can do now that we have our duck, so congratulations, you've imported a duck. It wasn't that hard, but we have a lot more to discover. You can try the other one. So we did for the duck inside the GLTF file. We can do it for the binary file. So it's the second one. If I do binary, and be careful, it's GLB. So GLTF binary. So they did GLB. Why not? I can test. And it's working. Great. Can I do the Draco? So it's GLTF Draco, and the name is duck.gltf. So GLTF Draco and duck.gltf. And no, there is an error. We'll talk about this later. And the final one is the embed one. You know, the one with only one file, but the file is quite heavy. It's this one. So it's going to be duck.gltf. And it's working. Okay, great. So just with this code, we can use the GLTF binary, and the GLTF embedded. Congratulations. Not the Draco yet. So let's try another model because, I mean, it's a cool duck, but I want to try the flight helmet, which is much, much better, much cooler. Cooler? Yeah. So it's models, flight helmet, GLTF, so GL lowercase, TF uppercase, and it's the flight helmet.gltf. Let me show you the folder. So it's this one. You can have a screenshot. As you can see, it's a beautiful model. So it's really small. That's not important. We are going to see it inside our scene. So it's models, flight helmet, GLTF. We have a lot of texture, and it's huge textures, and they look great. We have the normal map. You know the normal map. Anyway, we need to load the flight helmet.gltf. Did I put everything right? Yes, I think. I save, and I have nothing. Do I? Oh, I have something. I have the glasses. And you're probably thinking, no, I don't have the glasses. You have something like, I don't know, like a part under it, or a pipe or something like that. Let me refresh. Oh, no, I always get the glasses. That's funny. I usually get different results. Anyway, we don't have the full helmet. We just have one small portion of the helmet. Well, there is good reason for that. We added only the first child of the scene. Let's log the scene again. Look at what we loaded when we are using this model. And we have 5 elements in it. Actually, we have more. If I remove the scene add, we get 6 elements. That's important. We are going to see the problem later, very soon. So we have 6 children, and with the previous code, we were just adding the first one. All right, so it's wrong. How can we add all of them? It's not that simple. Hang on. You might think we just need to loop on it and add each child to our scene. Let's try to do it. For const child, I like to do for off, but you can try with other one. No, actually just test with for off. I don't know what you will get if you don't. We're going to have a problem. Let's have the same problem. So I loop through the children of the scene, and then I can add them, scene add, and add the child. All right. So I loop through the children of the scene property, and I add each one which are there, and there are meshes. So it's great. It's supposed to be working, and we get that. What the hell? What just happened? And if you refresh, let's see if I get different result. Yes, I did this time. All right, I didn't even get the same result. What is happening? And this is something where my students always struggle. I will try to explain to you. You have the scene, all right? I logged it, it's this one. I will log the GLTF. Just focus on my screen right now. I want to explain to you why we don't get every object added to the scene. You have one scene. Look at my hand. I have this scene. It's the scene I've been loading. I have this scene. It's my scene. I want to take the children of this scene and put them inside of this one. What I do is a for off loop. I'm just looping through them. When I take one here and I put it inside my scene, I get it inside my scene, so it seems to be working. But when I did that, it also got automatically removed from the children of that scene, right? It got automatically removed. So at first we have 6 children. We want to add those 6 children to this one. We took one and put it there, but now we only have 5 children. And this is what is messing with our for off loop, all right? Because we don't have any more 6 thing. And right now the loop is taking the second one, but we have less inside. So then we take one, we put it in the other scene, and we have one less. And we take the next one, we put it to our scene, and it's the end, there is nothing left. But in fact, they got moved inside that array because we were getting them off and putting them there. It's because they got removed from the previous scene and then added to the new scene, which is the problem. All right, it's just that they get removed automatically and it messes with our loop function. We have 2 solutions. I have 2 solutions to fix that. Maybe there is more solution, and I will try to explain to you. First, what we can do, so we have our array of children. We want to add them to our scene. We will take the first one as long as there is children left in it. All right, we just take the first one, put it there, test. Okay, there is some left. Take the first one, put it there. Some left, take the first one, put it there. Some left, take the first one, until there is nothing left. To do that, we can use a while. I don't know, we don't use much the while in JavaScript, but we can use the while to do that. So we will write something like while there is children left. So while GLTF scene children length superior to 0. And actually we can just write it like this, because when it's equal to 0, it's like false. So it's the same. Superior to 0 and this is the same. And then we add to our scene the first child from the loaded scene. So it's the same code as before, but we are doing it as long as there are children inside of that scene we just loaded. And as you can see, I get the whole model. So it's not as looking as good as the preview we can see in the website, but we are going to get a really realistic model soon, don't worry. Anyway, it seems to be working. We have every part of our GLTF model and it's great. So this is one way of doing, but I know that people are afraid of using while, and I know why, because if you mess with your while, you can freeze your computer, all right? And freeze Chrome at least, because the thread will be stuck. The other solution is to take this children array, which is the like a 3GS children array. It's kind of a special array. And we, instead of using that array that automatically get the children get removed from that array, we're going to duplicate it into a brand new array that has nothing to do with 3GS. This way, with this new array, we're going to take one and put it there. It won't get removed from this. And by doing that, the for of loop will work just like any for of loop. We take the first one, the second one, the third one, the fourth one, the fifth one, and the sixth once, and add them, and they won't get removed from that array, and we don't care about it. It's just a temporary array. We don't care if there is children left in it. So let's do that. I will remove this part, and I will duplicate the array. There are many ways of duplicating an array. What I like to do is first you have to create a new variable. It's going to be children, why not? And I'm going to do a new array. So this is the way of creating an array. It's just brackets, and use the spread operator, which is a cool JavaScript new feature. New, I mean, it's been years, but anyway, we didn't have that when I was young, and yet again, I'm getting old. So we use the spread operator, and if you want to understand what is the spread operators, you can say that it takes the values. So if you use the spread operator on the children array, which is exactly what we are doing, we are not taking the array that contains something, we are taking the values inside that array, and we are putting them inside a new array, because we created an array with those brackets. So right now we are just duplicating the array in a brand new simple array. And as you can see, here is my new array. I can remove this console log here. So this, yeah, I will just remove it, and I get a brand new array. And now I can use the old code I did, which is const child of children. So it's not in the GLTF scene children, it's my new array. So it's a duplicate of a clone of this one. And I can add them to the scene by doing scene add child. I save, and I get the whole model. Maybe you have to wait, by the way, because it's huge model. Even in local, it takes time to load it. So yeah, maybe you have to wait like a second or two. And it's working, all right? Use the version you like, while or duplicated array. Usually with my students, I use this one because it's more logical, and we learn about spread operator, which is great too. Anyway, let's move forward. So we learn how to load a very simple model composed of only one mesh. We learn how to load a more complex model composed of multiple meshes. And by the way, you can also add the whole thing just like this, which is the more simplest version, and you can perfectly use this. I just wanted you to practice loading only what you need and understand what you load when you use the GLTF loader. But you can also do scene add GLTF scene. Remember this, it's the group. I'm going to show to log it. Don't forget to comment the children stuff we did. If you log the scene, it's a group. All right. When you load a model, GLTF model, you get the GLTF scene, and it's a group, and we can just add this group to the scene. And with just one line of code, we get the right thing. I know, it's much more simple, and you can use that. So the next part is about the Draco compression. Finally, what is that Draco compression? Draco compression can be really helpful. First, let's try to load our duck. So we can use the same code, so GLTF scene, keep that and load the duck. So be careful, the path is quite hard. It's going to be duck GLTF dash Draco, I think, and duck GLTF, maybe. Yeah. It was the right path. I know I get an error because we are not supporting Draco compressed file now, but anyway, this is the right path. So make sure you have the right path and the same error as me. which should be something like no Draco instance provided. And we need to fix that. So yeah, what is Draco exactly? The Draco version can be much lighter than the default version. Let's see the weight inside our folder. So this is the Draco. We get something that looks like the GLTF. The GLTF was 123 kilobytes, and the Draco is 45 kilobytes. So it's more than twice the weight, and can be even better for some other models. But right now it's great. We have such a light weight. So it seems that we should use it. Not exactly. We are going to talk about when to use Draco. So yeah, the compression is applied to the buffer data, typically the geometry. This file, the duck0 bin, we can apply the Draco compression on it, so it's not that heavy, it's much lighter. So the Draco compression works on buffer data, like the geometry. Draco is not exclusive to GLTF, alright? But both got popular at the same time, and they just integrated the Draco compression in exporters and importers faster because they became popular at the same time. But you can use Draco in other formats. I never did it because I never had to, but you can do it. And Draco is developed by Google, and it's the algorithm. Sorry, the algorithm is under open source Apache license, which is pretty great. You can use it, and you can use it. Anyway, I put the links of the website and the repository in the links panel, as always. So, how can we add the Draco to our project? We need the Draco loader. And to load the Draco loader, so you have, I think you can have the documentation here. Oh no, not that. Okay. You can have the documentation here, and I don't think they are using GLTF, because you can use just Draco file. We are going to use GLTF Draco compressed file, which is kind of the usual usage. So yeah, let's import it. Like the GLTF loader, we cannot access to the Draco loader directly in the 3 variables. So we have to do Draco, it's in uppercase, the Draco part is in uppercase. And 3 example GSM loaders, it's almost the same, we just need to replace by Draco loader. Draco loader, yeah, that's it. We can save just to make sure that we don't have new errors, and you can log the Draco loader before the error occurs. And yeah, we get a function which is great. If you get new errors, maybe you did something wrong, check the path. Then we can instantiate it, and you have to instantiate it before the GLTF loader. It's not that important, but in our logic, in our code, it's better. So Draco loader equal new Draco loader. All right, I just write it this way in camel case by using the right class. Still nothing, because we now need to tell our GLTF loader instance to use it. Oh yeah, by the way, the G-code. We have to do something first. The decoder, the Draco loader, is available in WebAssembly. If you remember, we talked about WebAssembly in the physics lesson. It's not that important. It's just faster. All right. We won't talk about WebAssembly. It's way too big, and I don't master this part. So it's just faster. So we have a WebAssembly version, but also we can run Draco in a worker. And we talked about the worker too. It's when you put a part of the JavaScript logic in another thread of your CPU. This way you can have two threads working for you, and it can be like much faster, because when you have a Draco compressed file, you have to uncompress it. Your computer have to uncompress it, and it can take like few seconds if it's a huge model, and your computer will be freezed during those few seconds. We don't want our computer to be freezed for a few seconds. So we are going to use this worker version. We are optimizing everything at start. So to do that, we need to provide new files to Draco. Because remember, the workers has to be in a different part of the code, and we're going to provide them as a different file. You will understand. But first we need to get those files, and you have to follow me on that because maybe your 3GS version is different from me, which is why I didn't give you those files. All right, because 3GS is getting updates every month. Maybe they will change something about the Draco, so go get those files. They are located, and you have to go there in the forbidden folder. It's the node modules folders. Then you scroll to 3GS, you can just write 3. So inside the node modules 3 folder, and you have to go into examples, JS, libs. All right, let me show you the whole path. It's node modules 3, examples, JS, libs, not JSM, it's JS, libs. And inside of that folder, you will have the Draco folder. And you take the whole folder here. All right, I just copy it, let it inside. Don't touch the node modules. So just copy the Draco folder and then go back to the static folder, our static folder, and paste it there, right here. And inside there is the WebAssembly files, and this code will be run in a different thread because we are going to use workers. Don't worry, it's really easy. You just have to provide the path to this folder. And the path to this folder is really simple. It's just /Draco. And that's all. So yeah, let's provide this path. So it can work without it, but it's much better to do that. And it was quite fast. You just need to know where to get this Draco folder and put it inside your static folder. And you just do Draco loader set decoder path, and you just have to provide the path here, which is just /Draco, and I think you have to let the trailing slash here. So end with another slash. We save, still nothing, but right now our Draco loader will be able to use a much faster version with WebAssembly and with the worker, because the file is separated. Finally, what you need to do is to give the Draco loader instance to the GLTF loader. And we're going to do GLTF loader, set Draco loader. They did a great job here. Like it's really simple. For something that complex, I think it's really simple. So thank you for the guys that did this part. You just have to do Draco loader, all right? We provide our Draco instance, which is using WebAssembly and workers, to our GLTF loader by using the set Draco loader. You save, finger crossed, and we get our duck. But this duck is so much lighter. Like it's more than twice the half the size, so less than half the size, which is great. And by the way, you can still load a basic version. Like, see, I just load the GLTF duck GLTF file. It's working. And the great thing here is that the Draco decoder won't even be loaded. Right? This whole part, this thing will not be loaded. We provide it to the Draco loader instance, but this part will only be used if the Draco loader needs it. And because we loaded a non-Draco compressed version here, the Draco loader won't use it, which is great in terms of loading stuff. Okay, that's cool. So, when to use the Draco compression? Maybe you're thinking, yeah, that's a win-win situation. We should always use Draco. No. Because first you need to load those. You need to load this class. So the Draco loader class, maybe I can show it to you. It looks like this. As you can see, it's not that much, but that's kind of a lot of codes. All right, so we need to load this. We also need to load this, which is the decoder. All right, so we load thing in order, we load more things in order to load less things. So it really depends on what's the current way of your geometry. And our current geometry is, just look at this, it's 100 kilobytes. Is it really interesting to load the Draco loader to win like 60 kilobytes? I think maybe. I wouldn't use the Draco loader just for that, but almost. If you have like, I don't know, like 15 megabytes of files to load with huge geometries, okay, go ahead, use the Draco loader. If not, if it's just small geometries, don't. The next thing is about the freeze you may have. When you load the duck, yes, we are using WebAssembly and a worker, but if it's a huge geometry, you might get a freeze, meaning that when you open your experience, your WebGL experience, for maybe, I don't know, half a second, it will freeze. And it depends on how much the Draco loader has to uncompress. So yet again, it depends. It can be harder for the computer, but if you gain, I don't know, like 2 seconds of loading, but then you lose half a second of freeze, well, in that case, it can be interesting. So as always, it's up to you. It depends on the situation, on the project, and you will have to test and make the right decision. Next is about animations. We are almost done. We just need to talk about a few things. And the cool thing with GLTF is that we can load animations. So our dock is not animated. Actually, you can see that because if you log the thing we loaded, you can see that there is animations. We talk about this one, array, and it's empty. So this is not a good example. We are going to load an animated model, and good thing is that the fox is animated. So the fox is located here. So static models fox, and I got it from the same place, from the examples in the GLTF models repository. And we have access to many of those. We have the default one, the binary one, the embed one, embedded one, but we don't have the Draco. But anyway, we don't really care. It's just examples. So yeah, let's load it's the default one. So it's going to be fox, GLTF, and then fox, GLTF, like that. All right, load the right one. We can add the whole thing. And what do we get? Oh, what is happening here? When we refresh, we get something like that. So you might think, no, it's not working. Zoom out, and here is your huge fox. So yeah, there is a problem right here, and we need to fix that. But it's not that hard. Because we are loading a group that contains everything we need, we can simply scale that group, and we can do, just like we could have scaled the house, now we can scale the fox. So we can do a GLTF scene scale. So it's a vector of 3, so I can do set 0.025. You can test other values, but this is the one I use in the example. And we get a cute fox. Hello, fox. All right, the scale is fixed. This is not the goal of the lesson. How do we handle the animation? It's hard. I mean, it's not that hard, but it's a lot of work. And it's because you can do a lot with 3GS animations, like a character that run and then mix with another animation, and then this animation, and then go back in this animation in order to put the gun back, stuff like that. So you can do a lot. But we have also, like, if we just want to play an animation, it's going to be a lot of work too. Anyway, I'm going to explain how to do it. Do not worry. It's the end of the lesson. Hang on. That wasn't that long. So if you log this file, so I'm going to get rid of the comments I had. So it's all GLTF like this. You will see that the animations now have elements inside. And those are called animation clip. And these are 3GS classes. All right, you can read the documentation. It can be interesting. It's like keyframes, animation keyframes. To use them, we need to create what we call an animation mixer. An animation mixer, so it's a 3GS class. It's like a player. Yeah, you have songs. If you want to play those songs, you need a player. Then you will be able to play those songs inside your player. So yeah, let's do that. To create a mixer, when we can do it right here, we will do const mixer equal new 3 animation mixer. Mixer like this. And as the parameter, you have to provide the concern object. So for us, it's our GLTF scene. All the animation will be applied to that scene. Then you can take the song, so it's our animation clip, and add it to the mixer. To do that, you do make mixer clip action and use the animation. We are going to start with the first animation because there are multiple animations like the fox walking and the fox running and stuff like that. So GLTF, remember it was in the animations, and we're going to use the first one. And when you do that, you get what we call an action. So we do action, and we can log this one. Log action. I know it's far-fetched, but don't worry, it's going to work. So we get an animation action, right? We are talking about a lot of class. We have the animation clip, the animation mixer, and now the animation action. And in the animation action, you have access to what we need, which is the play, where is it? I won't be able to find it this way. So anyway, you have access to play method. So you can do action, play, like this. Finger crossed, and no, it's not working, unfortunately. Because now what you need to do, we did right, all right? Everything is fine. If you get an error, fix the error and get back to the lesson. But the problem is that you need to tell your mixer, so your animation mixer, to update itself on each frame, all right? This one, you need to in your tick function, to tell your mixer to update itself and provide the time. So how can we do that? Well, we can take our mixer and it's going to be something like update. So I go to here and I can do like update mixer and do mixer update, something like that. I don't know, let me check. It's going to be update, yeah, and we have to provide the delta time. We did that in the previous lesson for the physics, so it's just how much seconds were spent since the last tick. And we do that, and we get an error because we don't have access to the mixer. Why? Well, because we created our mixer inside the function. This is a JavaScript scope issue. To fix that, it has nothing to do with Three.js. It's just because we created a variable inside of a function, you cannot access this variable outside of the function. It's how JavaScript works. It's called scope. What you can do is create it outside by using a let, because you are going to change it, and do let mixer equal nothing. And I prefer to say equal null, so it's clear in my head, but you can do also that. It's going to be the same result, but I like to put it this way so it doesn't look like I forgot something. So let mixer equal null, and then inside of it, we are updating that variable, all right? So remove the const. So we create the variable outside, and we update this variable when the fox is loaded. But be careful, we did a mistake here. We can test it, so don't forget to add the mixer update in the tick. If you didn't, just add it. Save, and you will see something strange. Refresh. Oh, yeah. I hoped we could get a result, but we actually didn't get any result because we forgot one thing, is that it takes time to load the model, all right? So our mixer by default is equal to null. And after, I don't know, maybe half a second, the mixer will be our real animation mixer. So it should be working. But before, we have a mixer which is equal to null. So for few ticks, we have a mixer that cannot be updated because this is null. We have nothing in it. What we can do is if mixer different from null. So it's if it's something different than null, then we update it because it will be our animation mixer. Let's save, finger crossed, and this is your animation. So it's not working, it's just watching, searching for its prey, but still it's working. All right, get your animation working. It was maybe a little fast, sorry for that, but we have a lot of classes to use. And yeah, so it's working. What you can do now is test other animations. So we use the first animation with the 0 index. We can use the second animation. So now it's working. Great animation, by the way. And then the third one, which is the index 2, and now it's running. Really cool animation. They did great on that one. Okay, that's cool. finally, I want to talk about the Three.js editor. So it's over for the animations. We won't go further. I'm not an animation expert. I did use them a few times, but as long as I can play the animation, it's great. So that's the end for the animation. I want to talk about one last thing. It's the Three.js editor. If you type, I don't know, Three.js editor inside Google or anything, you get this. So it's the Three.js website, and when you add /editor, you get this, all right? This is like, how I like to call it, it's, let me find it. It's like a tiny online 3D software. So we're going to learn how to use Blender. Maybe you've been using Blender, 3ds Max, Maya, Cinema 4D, I don't know. It's the same. But inside your brother, yeah, it's a web tiny online editor. You won't be able to do the same thing as Blender, but anyway, you can have fun in here. And you can add, I don't know, let's say a box, and we get a box, and we can move the box and do stuff like that. Why am I talking about this? Well, it's because you can take your file, and let's say I'm going to use my duck. Let's start with the binary duck, all right? And I can drag and drop this duck here, and I get my duck here. So it's a good way to test things. When I have someone that, I don't know, a 3D modeler, he sends me the model, I won't just spend like an hour adding it to my scene. I will just test it inside that Three.js editor, which is really useful. And as you can see, we can't see much here. So we have our duck, maybe you can see just a silhouette here. And this is the camera. Remember that inside our duck file, we also have a camera. And this is our cube. We can get rid of the cube. By the way, you can destroy things too. And we are not able to see anything because remember that when you're using GRTF files, you get PBR materials, and PBR materials, so physically based rendering materials, are converted to mesh standard material. And what a mesh standard material needs? Lights. If you don't have lights, you won't see anything. So we can add lights. Just go to the add panel. You can add an ambient light. All right, looking great. The position is not important because it's an ambient light. And we can add a directional light, and now we get our duck. Looking good. But actually, it's not looking the same as our duck. See, the color is different. We're going to talk about this later, don't worry. We will get the same beautiful color for our duck. Duck. I always say duck. Okay, cool. We did that. So yeah, that's it. From now, we will only use GRTF models, but keep in mind that other formats can be more interesting, all right? For the next lesson, we're going to use realistic models, so it's great to use GRTF files, but there are many other files. Just find the best and choose the right format wisely. That's it for the lesson. I will see you in the next one.